Okay, lesson 46, simplifying expressions with square roots and higher order roots. So I know you'll have all seen a square root before, so let's go over quickly what the answers for those look like. So on example 1a, it says, what is the square root of 64? What is your answer? 8. Now, of course, that's our natural answer. That's where we learned that square root means what multiplied by itself equals 64. Now, there's another part to this, so you need to start considering it. What about negative 8? Isn't negative 8 times negative 8 a positive 64? So, since it is, negative 8 is also an answer to what is multiplied by itself and equals 64. Okay, so our answers need to start being considered like this. Just need to start thinking in this realm. Positive and negative answers for our square roots. Okay? So both negative 8 multiplied by negative 8 is 64, and positive 8 multiplied by positive 8 is 64. Okay, over here on B, if there's a negative outside of your square root, you do the square root just regular. So consider this kind of like a parenthesis, okay? It's a grouping symbol. So the square root, we need to find the answer for the square root, it's 3. And then the negative is on the outside, so consider that like the multiplication. Negative multiplied by a 3 is a negative 3, okay? And again, since there is also the negative answer for that, it'd be a negative and a negative 3 makes a positive. So we have both a positive and a negative answer again. Okay. Remember, if the negative's on the outside, that's how we're going to deal with it. Any questions on that one? So I wanted to show you the ultimate breakdown of how these end up working out. So, like I said, square root means what multiplied by itself equals 64. So on this one, it was 8 multiplied by 8. But remembering that 8 multiplied by 8 is the same as 8 squared, I want to make you recall that the inverse of square root is the squared sign. So these two will cancel each other out. The squared and the square root will cancel each other out. Now, just like there's an imaginary 1 in front of every x, there's this imaginary 1. Up here, there's this implied 2. Okay? It's the square root. It's saying how many times it's being multiplied by itself. So if I said the cube root of something, for example, the cube root that has a 3 right there of 27, that's saying what multiplied by itself 3 times is 27. The answer would be 3. Okay? So on a square root, because we say the word square, it has that implied 2 there. For any other roots, we have to put the number. Okay? So these two things cancel each other out, is kind of my ultimate point. So it works every single time. So we have the square root of 9 that breaks down into the square root of 3 multiplied by 3, which is the square root of 3 squared. And again, those cancel each other out, and all we're left with is that negative 3. Okay? And then we have to consider the positive answer of it as well. Okay, this one's fairly obvious, but I want to ask it just in case. What multiplied by itself is 0? 0. Okay, no ifs, ands, or buts. It's not a positive and a negative 0, so just write down 0. D. On D, this one breaks it down into a fraction form. It has the whole thing underneath the square root. So we're going to deal with this kind of like distribution. So when I rewrite it, it looks like the square root of 4 over the square root of 25. Okay, so when I get my answer, it's going to be 2 over 5, because what multiplied by itself is 4 is 2. What multiplied by itself is 25 is 5. Okay, and again, that's going to be a positive and a negative answer. Okay, I just want to get you in the habit of seeing this plus or minus sign. For the means of your Algebra I class, we're going to pretty much always have positive answers. Okay, last example here. E. It says, what is the square root of negative 36? Now, why is it not possible to have a number multiplied by itself be negative? Does it always equal positive? We have that rule that says same sign sum, right? So if it has the same sign, it's going to be positive. So if I multiplied a negative 6 and a negative 6, I get a positive 36. If I multiplied a 6 and a 6, that would give me, again, a positive 36. So there is no real solution for this. There's an imaginary solution, but there is no real solution. So no real solution. And that's how you'll write your answer in on that one. Okay, any questions so far? Anytime you see a negative underneath a square root, has to be a square root, or an even root, you will automatically know there's no real solution. So if it said the fourth root, then again, that would still be no solution because it's an even number. All right, let's talk about what the cube root looks like. This can be written, let's just do examples. Example 2a. It says the cube root, so we do the same kind of square root symbol with a 3 right there. The cube root of 64. So again, this is asking us what multiplied by itself 3 times is 64. So if you don't know the answer, you can whip out your calculator and start typing in numbers, multiplying themselves by themselves 3 times, and trying to figure it out. So here, this is going to be a relatively small number, okay? So I'd start out with 2, 3, 4, 5, and move my way up. So I know 5 times 5 is 25, and 5 times 25 is 125, so that's too big. I'm going to move my way down. 4 times 4 is 16. 16 times 4 is 64. So to answer the question, what multiplied by itself 3 times is 64, I'm going to put 4. Now it's only positive 4, okay? Because if I multiplied negative 4 by itself 3 times, I'd get a negative 64. Notice this is an odd root. Okay? You can have a negative with an odd root. So to exhibit this example, we're going to have the cube root of negative 8. Again, smaller number. So what multiplied by itself 3 times is 8. 2. Okay? Now I have to consider this negative. Negative 2 times negative 2 is positive 4, right? So let's look at it. Negative 2 times negative 2 times negative 2. Okay? Negative 2 times negative 2 is a positive 4, but when I multiply it by this last one, I get a negative 8. Okay? So that'll only work with odd roots. I can only have a negative underneath it if it's an odd root. Okay, next one. C says, what is the fourth root? So here we go, there's the 4 right there. Again, this is an even root, so we can't have a negative in here. What is the fourth root of 81? So what multiplied by itself 4 times is going to give us 81. And we start either going through the possible solutions or think rationally. If you think about what this is going to end up being, okay, so I'll give you the answer and tell you what. We'll work backwards from it. So the answer is 3. So it gets 3 times 3 times 3 times 3. What this ends up looking like is 3 to the 4th. But it also could have been rewritten as 3 to the 2nd times 3 to the 2nd, which is actually 9 times 9. So a fourth root can be broken down twice. So it's a root contained inside of a root. So to break it down, it would look like 9 times 9, right? On the inside of that, what with the fourth root. So you can do this as an easier problem at first. You go, okay, what multiplied by itself is 9? Or sorry, what multiplied by itself is 81? And you go, okay, 9. So you break it down into 9s and you go, okay, what multiplied by itself is 9? And then you can break that down into 3s. Okay, so these ones that are even can be broken down and made just a little bit simpler and get us our final answer. Anyways, just that's a quick hint. Okay, continuing on, part D. We have a fourth root, again, but this one's a negative 1. What did I say about even roots? What can you not have underneath them? You can't have a negative. So what does this tell us about our solution? There's no real solution. It is important that you write real solution in here, because there is an imaginary solution, but there is no real solution. You'll start learning about that later on. The answer would be I, specifically. That's why we don't use I as a variable. At least we try not to. Okay, any questions? Okay, I want to give you just a little bit of a rule here. When you see the square root of something, I'm going to say x. You can rewrite this as x to the 1/2 power. Okay? If you want to rewrite it as a power, it is to the 1/2. Now, if I said the cube root of something, let's just do x again, I can again rewrite that as a 1/3. Same concept goes with to the 4th root. Okay, I can rewrite that as a x to the 1/4. So if I want to use these as fractions, I can do that by rewriting them. So there's a interesting thing about these. If we had x squared, but it was being 4th rooted like that, I would rewrite it just like this. I would rewrite my x squared, but I have to remember that this is my root, and what did I do with it here? I just put it on bottom. So same concept goes here. 4th goes on bottom. Now, if you get confused about any of this, remember where the roots grow. They go underneath the ground, right? So there's your ground. They go underneath. And again, we can reduce that 2/4 to 1/2. And there's our final problem. Okay? So as a general rule, if you want to write down the general formula for it, you can. It's x to the whatever the power is over, let's do, I'll call it r for root. Okay? So it will be rewritten as x to the n over the root. Okay, so that's what our general formula looks like. N is just the exponent that was attached to our base, and r is the root. Okay? You'll see that a little bit. So now the reason why these break down so nicely, and why one is the inverse of the other, okay, I told you that square roots and squares are their inverses. So let me show you what happens when you use these rules and apply them to the square roots. So here we go. Since this is a square root, it's going to be a 2, so it turns out I just rewrite the part underneath, the radicand, that's what that's called, the radicand, and then I put the root on bottom. So it just becomes a 2 on the bottom. So x2 divided by 2 is just x to the first, which is just, again, x. So that's why those are inverses of each other. That's that rule kind of explained. I guess you don't really need to know it if you can do it. But all right. Example 3, we're going to start breaking these down, using them a little bit. A says 216 to the 2/3 power. So they're wanting us to work backwards from this and find a way to write it down. Is it 1/3? I'm sorry. Here's zoom in on my page here. To the 1/3. So if I rewrite this, it ends up being the 3rd root, because the 3 is on the bottom, of 216. So the question states basically, what multiplied by itself 3 times is 216? So there's a neat deal on your calculator if you want to start using it. You probably already used it a little bit. Turn calculator on, obviously. Okay, clear out anything that's there. I have 216 to the 1/3 power, but I need to know how to rewrite these, so don't forget that part of this. But if I want to find out 216 to the 3rd power, I type it in, 216, and I raise it. Here's a little caret right there. Okay, that's what I call it, is the caret. Raise it to the 1/3. Now I do remember that 1/3 is just 1 divided by 3. So that's all we're hitting. Press enter. Very simple then. Okay? Use our calculators to our advantage. Is anybody not able to get that? Okay. So there you go. Because your calculator only gives you a positive answer here, okay? Unless you specifically put stuff in parentheses in a certain way. You have to be careful. You still have to know, is this answer going to be positive and negative, or is it going to be just positive or just negative? Because this is a odd root, and this is positive, it's going to be positive. Okay? On part B, it says negative 27, and notice that it puts it in parentheses. Had this not been in parentheses, we'd get a completely different answer. wants us to rewrite it. So I need to rewrite this as a cube root. I know that because of the 3 on the bottom. I'm going to put my radicand right underneath, so negative 27. So what multiplied by itself 3 times is a negative 27. So let me show you how to do this, because it'll make a difference when you have an even root. So open parentheses, because that's exactly how they had it right there. I'm going to put it in parentheses of negative 27, close parentheses, raised to the power of 1/3. Whoop, I need to put that in parentheses. 1/3. There you go. The answer is negative 3. And that should coincide with what we said. Again, an odd root means we keep the sign. Okay. Odd root means we keep the sign. On C, it gives us 10,000 raised to the power of 1/4. Okay, I need to rewrite that. So it's the 4th root of 10,000. 1, 2, 3. Okay, so 4th root of 10,000. I ask myself, what multiplied by itself 4 times, 1, 2, 3, 4 times, is going to give me 10,000? This one's fairly easy because the number of zeros that are here is obvious. The answer is going to be 10. But if I wanted to type this into my calculator again, I have 10,000 raised to the power of 1/4. I get 10. Okay. Now, since this is an even root, I have a positive and a negative answer that goes with this. Because if I take negative 10, let me show you, negative 10, and I raise it to the power of 4, my answer is still positive 10,000. Okay. So I have both a positive and a negative answer. Anytime I have an even root, I have a positive answer. Okay. And a negative answer, sorry, positive and a negative answer. On part D, I have negative 256 raised to the power, notice that it's in parentheses, of 1/4. I'm going to rewrite this as a 4th root, so there's my 4, of the radicand 256. Again, I could use my calculator for this. I need to put it in parentheses, negative 256, close parentheses, raised to the power of 1/4, close my parentheses, and I should get an error. There you go. It even tells you what to write. You have a non-real solution, so that means that there is no real solution for this problem. To recall our rule, if we have an even exponent, or an even radicand, an even root, and a negative radicand, then there's going to be no real solution. So let's write that down so that we have it established. I'm going to use the square root of some number, let's call it x. And we'll use r for the radicand. Okay? So use r for our root. Sorry, not radicand. So if r is even x has to be positive. Let's not say x is positive, but x has to be positive. And there will be both a negative, and the solution will be both positive and negative. If r is even, x has to be positive, and the solution will be both negative and positive. On the next part of this rule, if r is odd, the solution will have the sign of the radicand. So if r is odd, the solution will have the sign of the radicand. Any questions on that? Okay, last example then. Oops, that's my line. Okay, on the last example, it gives a package, very nicely done right there. A box, a gift box in the shape of a cube has a volume, so volume, of 3,375 cubic inches, so inches cubed. Oops. So next, I want to think about what the shape of this box really means, okay? So if I have a cube, we're going to call it side length S, okay? What do I know about every one of these cubes' side lengths? They're what? They're all the same. So its height is the same as its width, as the same as its length, right? So each side is just S for the meaning of this. And how do we find the volume of a cube? So it's, I heard base times height times width. So I want to use length and width, so I'm going to use length, width, and height. So to find the volume of a cube, I take the length, I multiply it by the width, then I multiply it by the height, and which in this case was all S. So it's S times S times S, which is actually S cubed. So when I rewrite this problem, I'm going to consider the fact that S cubed is my volume, and my volume is 3,375 inches cubed. Okay, so to find this answer, because I want to get rid of this 3, I have to cube root each side, because the inverse of to the third is the cube root. So that one went away. So now I have the length of each side is whatever the cube root of 3,375 is. And I can rewrite this so that I can do it in my calculator as 3,375 to the what power? To the what power? That's a question for you guys. To the 1/3 power. So type that in your calculator, tell me what you get. 15? I don't disagree. So 15, and it needs a label. What is that label? Inches. Good. If my number, for some reason, came out negative after I typed into my calculator, what would I definitely know? Think about it. Can you have a negative side length? What would I know about my answer? It's wrong.